Hello everyone. Today we are going to create the system to spawn the player. The first thing we are going to do is to import our character. So let's grab the props and the character itself. Import everything. Okay, once imported, we have this new folder with our model and some props. This is a commission work I requested, I paid for. And let's organize a little bit the folders. So we are going to create under our LH folder a new one. Let's call it models. Then characters. Okay, so from here we could move the hunter folder inside the characters. There we go. And let's do the same for the models, but for the props, but inside the models folder. There we go. Then we have the textures. For this model we can see that everything was imported correctly. The props, we have the lamp, pistol, and the saw cleaver. Inside the hunter folder, let's create another one and call it animation. Animations. And let's import the animation we have onto that one. Which is animation I made with U-motion in order to get the fist closed and the left hand holding the pistol. Okay, so finally for be able to delete this art folder, we need to move the materials and the texture for the props. So let's check. Let's just move the materials folder inside the LH folder. And the textures, we already have one, so let's just move the props folder inside the textures. That way we can stay organized. And now it's safe to delete this one. And let's make the prefab for the player. So open up the models folder, characters hunter. Let's check for the FBX. I do have already a prefab here, but we are going to change this one. So let's go back to the FBX. Let's select the empty scene and drag the FBX onto the scene. click on Scene View, press F, and there we have our character. So let's make an empty game object as always, not as a child, and let's call it player. Let's zero out all the transform position. Now we can drag the Hunter FBX as a child of our player game object. So this will allow to have all the logic in the parent game object, and we can switch whenever we wanted the mesh, which is only art. It should not contain much of logic at all. Okay. So for this player we need a capsule collider, and let's change their settings to center Y 1.1, radius is okay, and height 2.2. If we click in the edit bound volume, we can see actually the size of the capsule. We also need a rigid body, and we need to freeze the constraints, freeze rotation. Let's close it up. We also need a photon view component and a photon rigid body view, which was already added automatically in the observed components of the photon view. From this photon rigid body view, we need to check enable teleport for larger distance. We can leave it the default for now, and synchronize angular velocity. Basically the angular velocity is the rotation speed of the player, how fast they will rotate. Then we need to create a script to switch the rigid body is kinematic, whether we are the owner of this player or if it's the client side of the player. So for that, let's go to our mono behaviors, since it's a mono behavior that we need to add here, and create a folder. Let's call it utilities, and the script we can create is going to be rigid body deactivator, so we know right away what this script is doing. And let's Unity compile, and let's open up in Visual Studio. Once open, we need to add a using statement for the photon one namespace, and let's add a little comment for you. This is utility script that deactivate the rigid body when it's not owned. So we need to hold a variable for the rigid body to be cache. Rigid body. We need to hold to cache the photon view. In the awake method we cache those by checking the component, get component rigid body and photon view, get component photon view of type photon view, and in the start method we check if the photon view that we have is not mine. Then we set the rigid body is kinematic to true. Simple as that. So let's go back to Unity and let's add this component to our player. There we go. So the next thing we need to do is in the Hunter mesh we need to create a socket or places where we need to attach our weapons. So if we start opening the hierarchy, we see we have the left shoulder, right shoulder. So let's continue until we get to the left hand, and from here we need to create a new empty game object. Press F2 to rename it, and let's rename it weapon socket left hand. And let's change the transform. This is something I playtest before, so just bear with me. Minus 0.295 minus 0.064, and the set of the position 0.14. Then for the rotation we have in the X 5.225, in the Y minus 60.257, and in the Z minus 87.54. Okay, so let's do the same for the right hand now. And let's add another empty game object, and in this case let's call it weapon socket right hand, and let's change the settings of the transform. So the position X will be 0.33, the Y minus 0.057, the Z 0.211. Then in the rotation we can leave it X and Y as it is, but the Z we need to change it to 88.15, and that should be it. Okay. So after doing this we can safely now create our prefab. And for a photon to instantiate a prefab, they need to reside or live into the resources folder. So we have already one here where we had this .twin settings. So let's just drag it up there, and there we go. We have our prefabs. But we need to fix the materials. So let's go ahead and do that as well, because we already made the prefab. This will take an account like we are changing the prefab itself. So let's go to the prefab, open prefab, and let's apply the materials. So we have default material, and let's go to the Hunter, Hunter body, and that's it. Right, so I have autosave, so the prefab was saved already, so let's move on. So from this empty scene we can now safely delete the game object, and then we need to continue by creating the animator controller for this player. For that, let's go to our LH folder, data. We have our settings folder. Let's create a new one and call this animators. Click inside the animators, and then from the create option, let's select animator controller, and let's call it this one humanoid. Let's open up, and then let's go to our animations folder and drag the animation. Make sure to click on foot IK to avoid the sliding of the foot, and next we need to go to our prefab to assign this animator controller. Open prefab, and let's drag in the hunter object the animator controller. We can leave it as it is right for now. Okay, so we are going to add a settings or change the settings file in order to have player configuration settings here, and attach or add our player prefab so it's globally handled like it should. So let's bring up the game settings data script in Visual Studio, and let's add another serializable class. Public class player settings. Inside this class we need to have a variable to hold the game object prefab, so player prefab, and then we need to have a reference to this class over here. So let's create a header section, and let's call it player settings. Also let's give a space as before to F. And let's add our public player settings player config. Save the file, go back to Unity, let it compile, and once it compiled, let's go to our scriptable object, game object, and now we can have these settings here. So just drag the prefab player into this slot, and we are done with the settings. So the next step is to create several components to hold the game object, the photon view, the rigid body, also our spawn point. So let's go to the components folder. Let's make another folder here and call it game. So we know that all these components will be game context related. And from here let's add all the components and let them modify them. So component game view component, I will close Visual Studio to avoid this behavior. Create another component, local player component. I'm going to add another one and call it photon view component. Yet another one, and let's call it rigid, or let's say physics view component. And the last one is going to be Entitas Component spawn point component. Okay, now that we have everything, all the components, we need to add the logic on them. So let's start by the game view component. Double click to open Visual Studio. So in the game view component, we need to add our game object, public game object. So we need the using statement for Unity Engine. We don't need this one. And let's add game objects. And also we need the transform. We can leave the game context as it is, and let's add a few comments here. Stores the game object and the transform associated with the entity. Okay. Now let's open up local player component. And also, let me just open everything so we have them already in Visual Studio. Okay, so local player component. This one is going to be a component of flag type, so it's going to return whether we have it yes or no, or true or false. Nothing to reference here, but what we need here is to set that the local player need to be unique, so just one component need to live in the client for this component to be on. And let's just add a comment, flag component, that indicates the local player. That's it. Okay, moving to the photon view. As you could imagine, we need the reference to the photon view component here. So let's add public photon view, and let's add value. Let's remove this one and add a comments. Stores the photon view associated with the entity. Done. Now the physics view, this is going to hold the rigid body. So let's add public rigid body value, and let's change this using a statement for Unity Engine, and add a comment stores the rigid body associated with the entity. And lastly, the spawn point component. So for this one we also need to be unique, and here we need to store the vector tree of the position and the quaternion for the rotation. So we can add here the using Unity engine public vector tree position and public quaternion rotation. Okay, let's save everything, go back to Unity, let it compile. And then, since we added new components, we need to go to the tools, Geni, and generate, or Shift Ctrl G. This will generate wrappers for all these new components. We can go into the generated game context components, and yes, we have all this wrapper for us. Next we need a couple of systems, one for create the spawn points and the other for actually create our local player. So let's go into our systems folder, and let's create a new folder and name it game. And here we need a new system of type initialize system, and let's call it create a spawn point system. And now that we are here, also let's create the second one, create Entitas initialize system, and let's call it create local player system. And let's open up in Visual Studio. Okay, for the create spawn point system we need some references, but we are going to hold a list of transform objects that will be our actual spawn points, and then we can use this spawn point component that we created before in order to add, remove or update it. So let's add our using a statement that we're going to need. So we need using systems collections generic, we need Unity engine, we have already Entitas, and also we need photon pon. Okay, so let's add a quick comment here. This system that selects the right spawning point for the local player. So we need a reference private read only to a list of transforms. Let's call it spawn points. we need also a reference for our game context. In the constructor we need to add or the requirement to get this list of transforms. This point, if I can type points, and assign the references. Spawn points, and for our game context, from the context, the list of context we are passing here in the constructor, we just retrieve the game. Okay, so for the initialize, remember this is called in the start awake method of the mono behavior. So we need to add the transform spawner, and from this point list that we are passing here, we need to retrieve an index, and we are going to use the photon network local player actor number -1. This is a number that Photon adds to the already created player, so this will guarantee that we are not reusing the same spawn point. Now in the game context, now that we have our spawn point component, we have this replace spawn point method wrapper. So spawner, we pass the position, and we need the spawner rotation. You remember the component is expecting a vector tree and the quaternion. Save the file and let's go to the local player system. This is the system that will actually create the local player, so let's add a reference to Unity Engine. And let's add a quick comment here. System that creates the local player. From here we need, of course, our game context, because all the player related components are stored in the game context. So private read-only game context. And also private read-only the settings context. Settings context, because we are storing the prefab game object in the settings file, remember. So in the constructor we just need to assign our requested context. So from the context list, game, and settings context settings, and in the initialize is where we are going to do our magic. So game context is local player equals true. This again, this is the component we added. Remember, this is local player component, which is a flag type of component. So we are saying that the local this system will create a local player. Then let's add a game object. Let's call it player view, and let's request photon network instantiate, and here we are going to pass several things. We need the prefab name, the position, the rotation, and other two options that we are not going to cover in this video. So from the settings context we can go to our game settings. We obtain the game settings data, and from here we can go to our player config that we created, and let's check for our player prefab game object name. A little bit longer, but works. Next, for the position, we want game context, spawn point, component or entity, position. And the rotation, same thing, spawn point, rotation. And let's, for the last one, let's pass 0. Okay. So this will instantiate a game object for us, and now we have this player view game object. Then we can get the game entity. Remember, this is in the game context. Let's call it local player. So game context, local player entity, retrieve the entity that has this flag set to true, local player, add game view. So we have our player view, which is a game object. Remember, the game view component requires a game object and a transform. So player view is our game object, and from the player view we can retrieve the transform. We also need to add a physics view. This is the rigid body, so player view, get component of rigid body. We need to add player view, add photon view. So player view, get component of photon view. And that should be it. Okay, so let's say the file, and let's go back to Unity to compile. Once compiled, we can now go into our scenes folder and double click the sandbox, and let's start dressing up this scene to make it work. So the first thing that we are going to do is create another script that is going to call our systems that we just made. So let's go into mono behaviors. We have already Bootstrap launcher system, so let's call this one, create a new script, sandbox, sandbox system. Let it compile and open in Visual Studio. So this script is going to be some sort of repetitive, so we need, using Entitas, we need a system collection generic to hold lists. For our spawn points, and of course we need photon bomb namespace, and this mono behavior need to actually inherit from mono behavior upon callbacks. Okay, so here we're going to have a variable serialized field, private list of transform. Let's call it spawn points. we need also a private transform. No, this one we are going to do it later on, so let's call our private systems. This is a collection of systems from the Entitas namespace, so systems and private context, plural. There we go. So in the awake method we can create an instance of this context list by calling the share instance. This is a singleton from Entitas, and then we can create our new systems feature. It's just to group systems, so game systems, and here what we need to add is our actual system that we created, initialize system. So add new, create spawn point system, and remember this one is expecting the list of context and also the list of transform. So let's pass this on, and next we need to add our new create local player system, which is only expecting the list of context in the constructor. There we go. In the start monobehavior method we can call not the reference, actually yes, it's the reference context. So here since this is a list of all the contexts in the systems, so we need to retrieve the network one we created in the previous video and check its pending connection flag and set it to false. So if we get here, we are not we don't have a pending connection anymore. And from the systems we need to call the initialize method, which is basically, you remember, the create local and create spawn, this one. So it will execute. It is very important to get the right order when creating the systems. And finally, in the update method we can call whether we have an execute or not, and of course a cleanup. To release any resources, unused resources. Okie dokie. So let's go back to Unity, and after compile let's start making this level. So let's create a empty game object that will hold our systems. Let's drag the sandbox system onto it. We need to create game objects for the spawn point. So in the scene, let's start playing with this thing here. So we have main camera, directional light. We can delete this text now, we don't need it anymore. And let's see, let's create an empty game object. Let's call it Enviro. Let's create another empty lights or lighting. So let's move the directional light here. Let's add a 3D game object plane for our ground. Let's call it ground. and let's change its size to something bigger. So 20 in the X and 20 in the Z. We are in ISO view, so let's change to perspective. Okidoki. Let's change the lighting a little bit, so let's say 180, and let's white light. Let's have this real time to mixed and no shadows. Render more important, and yeah, and let's add another one. So light, directional light. Let's call this one main light or sun. And let's see, directional is okay. I'm going to switch it to white in the color and decrease the intensity 0.8. In this case we want, let's put hard shadows. Just use quality settings. We need to change this to very high resolution to actually have a better quality, and the auto, let's change it to important in the render mode. Okay, so what we can do now is to drag our prefab to see how it looks. Reset the component to have it in the center and press F to switch to it. So let's check the camera. Okay, what we can do here is probably select a view that we can switch to, and from the main camera game object go to the game object menu and align with view, Ctrl Shift, and there we go, have the same view on both sides. Alright, so this is the zero position of this scene, and from here we can create now the game object that we hold, the spawn points. So this also belongs to the environment, so let's create a new game object and let's call it spawn points. And let's just create a couple of them. So for now, spawn point. Let's do it sp1, spawn point 1, and sp2, spawn point 2. So to have better visibility, I'm going to assign a gizmo to it, this one. So if we drag the second one, let's hide the player. So you can see that we have here our spawn point. Let's put it back on 0. And let's move this one a little bit to the right and change its rotation so it will be facing us or facing the first spawn point. So let's change 180 in the Y rotation. Let me check. I think it's a little bit forced, so let's just move the view a little bit closer to the player And again, let's change the camera to align with view so we can see both spawn points. Yeah. So let's go back to our systems folder. Let's just move it on top and assign these two game objects to it. There we go. Save the scene, and we are good to go to test. So let's switch to our bootstrap scene and Ctrl P or hit play. Test, start, and there we go. Our player was spawned. So if we go to network, we have connection successful. We have our game context with 3 entities. The player name component we made last time, test, the spawn component, and the game view component, which is a clone of our player prefab with a transform, photon view, rigid body. Okay, so everything is working as expected, and this is our game systems. Alright, so now to actually play test the multiplayer, let's make a build and launch from the build. So what I'm going to do is go to the build settings, make sure that all the scenes are here, and then go to the player settings. I'm going to make a small change in the resolution and presentation, since Unity removed the option to change the window size. So let's make this one window, and let's change this to 960 for 540. That should be it. Let's save it, and we can now build our scene. But before building, I always like to switch to an empty scene for reasons. So let's click build, select our build folder, and let's do this. I will pause the video. Okay, so the build finished. So let me just close this one, and let's check the folder again, and let's open a couple of instances. And let's join this one first. Test, test, and now this other one. And there we have it, the 2 spawn points. You can play adding 2 more to reach the limit that we set it in the settings file, a limit of 4, and of course make this scene nicer, like a real level if you want. So let me show you, for example, the project I'm working with. Let me close this one. So the player is gone from the client here, and let me show you. Okay, so this is just a showcase what you can do with the actual level if you want. So this is what we are going to be making in the next video. The camera system to look at the player, and also have movement, and later on we are going to work on the animations of course. Alright, so thank you for watching and see you on the next video. Bye bye.